This is a setup of MagLog for an airborne survey. There are several ways to start the MagLog software. You can find the MagLog icon on the desktop. However, if it is difficult to find, you can click on the Start menu, go to All Programs, find Geometrics, and inside Geometrics you will see MagLog. And you can start MagLog by clicking on it, and we'll get the basic MagLog window. To get started, the first time, we're going to make a survey with the survey wizard. This survey will not contain all of the instruments for your survey, but it will have the magnetometer and GPS data devices semi-automatically configured. Then we will add the radar altimeter to those once we've got the basic survey set up. So to begin, we click on File, then we click on Survey Wizard. A Survey Wizard dialog box appears, and we will fill in each section and click the next button as we are prepared to proceed. To begin with, on the first window, there's nothing to do but click Next. The second window has a location for the survey, a Browse button, and survey units. You may choose meters or feet for survey units. It is recommended that you always use the Browse button to make a new survey, because the Browse button will let you choose a directory on your disk that would be appropriate for placing your data. Usually the best place to start is MagLog data, and then it is usually a very good idea to make a new folder for each survey area or each survey project. So we're going to make a new folder, and so we're going to call this folder Video Demonstration. Press enter again to open the folder, and now we'll make a survey, and we're going to call this survey Video. Survey name should have something to do with the area or the type of survey that you're doing, just to make it easier when you're processing data to understand where the files came from. We click Save. And now we can see that we have our new survey name in the survey file name with a different location, video demonstration in this case. Survey units will be meters, and we will now click Next. And we'll get to the GPS serial port setup. It is important to know in advance which COM port each of your serial devices is connected to. In this case, we've already done some investigation, and we know that the GPS is connected to COM6. It is helpful also to know the baud rate of the device that you're connecting, and in this case we happen to know that the baud rate of this GPS is 38,400. Once you've selected a port and a baud rate for the GPS, if the GPS is connected and powered up, you can click the Auto Set Communications Parameters button, and MagLog will attempt to detect data coming from the port. When you click the button, you'll get another little box up that warns you that this can take some time if you have incorrectly selected a port or a baud rate, or if the GPS is not turned on. Click OK. And generally, if the GPS is connected and the baud rate is correct, you will get a GPS has been detected message almost instantly, certainly within 20 seconds. Click OK. We can set warning messages under the GPS quality control. We can check the box if a GPS differential fix is required for the survey. It won't change recording of the GPS, but you will have a warning message anytime you lose differential corrections. You can also select the minimum number of satellites. We generally select 4 for the minimum number of satellites. That way, if we drop to less than 4 satellites in use for the fix, which causes the GPS to only produce a 2D fix, we'll get a warning message and we'll know that we only have a 2D fix. After we've set up the GPS, we click Next. And we get GPS Display Properties window. It's usually best to go ahead and click Next on the GPS Display Properties window, and any custom setup of this can be done after the survey has been started. This takes us to the first of the magnetometer setup screens. It's sets up similar to the GPS. First we pick a COM port. Again, we must know the COM port that the magnetometer is connected to. In this case, the magnetometer is connected to COM port 5. The baud rate for Geometrix 823 magnetometers is set at the factory at 9600 baud, except for custom orders. So 9600 baud is generally the correct choice. Again, we can auto-set communication parameters by clicking the button to check that there is magnetometer data on that port at that baud rate. We get a similar warning to the warning that appeared when we checked communication parameters for GPS. Say OK by clicking the button. And soon thereafter, if there is a magnetometer connected and it's powered up, we will see magnetometers has been detected window. Click OK. Now we can select the type of magnetometer under hardware type. Hardware type has a number of choices. Some of these choices have to do with magnetometers used for marine, and some of these have to do with magnetometers used for airborne. With a single magnetometer for airborne systems, the correct choice is 188X/823 mag system. If we were to choose one of the other choices that starts with 1, such as 188X823 mag with depth sensor, an additional analog channel would be enabled in the magnetometer that would digitize depth information if depth information were presented. Airborne magnetometers seldom have any data connected to their A to D ports, so we generally don't choose anything other than 188X/823 mag system or 2 88X/823 mag systems. The default cycle time is 0.1 seconds, which is 10 hertz. Default behavior for Geometrix airborne magnetometers is to output data at 10 hertz. However, you may choose data rates from 1 hertz to about 40 hertz and get reasonable behavior and reasonable accuracy out of the magnetometer. For the purposes of this survey, we're going to leave the default 10 hertz or 0.1 second cycle time in play. We type Next. The program is going to attempt to communicate with the magnetometer and will send configuration messages to the magnetometer to set the baud rate, set the speed, and once that's finished, the dialog box will automatically close. If there's a communications problem, the box will stay open and we would have to take some additional steps to close the box. The next dialog box is real-time layback, so you can see in the title of the box. You may choose to real-time layback. It can be helpful to have that to speed data processing on a survey. It does take a little bit extra disk space to store data for the real-time layback. So if you had a computer system with very limited data storage capability, then you could elect not to choose the real-time layback. So we'll, in this case, we'll leave the layback on. We'll say next. The layback parameters has a picture of a boat and a picture of a marine magnetometer. Our marine magnetometers and our airborne magnetometers use the same electronics and sensors, just different housings and enclosures. And we elected to have a picture of a boat and a picture of a marine magnetometer because the shapes are easy to recognize. The first entry on the layback parameters dialog box is central meridian. Central meridian is a number ranging from 0 to 357, indicating a general position on the globe. This number will come automatically from the GPS if the GPS is connected and getting a fix at the time. Offset parameters are mostly for layback calculations for our marine system. For an airborne system, the GPS winch distance is set to 0. And the magnetometer layback is set to 0. And the GPS offset, starboard offset, is set to a number that matches the left-right offset between the GPS and the magnetometer. If the GPS is mounted on the center of the helicopter and the magnetometer is on the hook, then the GPS starboard offset would be 0. Next dialog box shows us a list of the various fields that will be recorded in the interpolator file, which is a product of the real-time layback calculation. Next is the beginning display setup. We can choose whether the display orientation is generally horizontal or generally vertical. It makes no difference to the recording of the data or data quality. Whether you choose horizontal or vertical is just a matter of personal choice. We can also choose the beginning colors for the traces and for the grid. It is sometimes better to have a dark color for the trace 1 and something that's red or brighter color for trace 2. That appears to help with some displays, but again, that's a personal choice. The light green for grid color will work in conditions where there's not too much ambient light. However, if it's a very bright helicopter, then it may be helpful to choose a darker color for the grid color. All of these items can be changed while you're recording data. Next, we have slot duration, which by defaults to 60 seconds. Time grid interval, which defaults to 10 seconds. And slot type and scale and grid settings for the magnetic field and signal. Magnetic field, a scale of 10 and a grid of 5 is a good beginning place. This may be adjusted depending on how dynamic the magnetic field is in your survey area. For signal, the default settings for signal will be sufficient for most surveys. Next. If you have a dot matrix printer on board your ship, you may choose to plot data on the dot matrix printer. This is not a terribly popular device to have on an aircraft due to the problems keeping a printer running in a high vibration environment. So usually do not check the box use parallel printer and choose next. Next wakes up a Windows printer setup. Again, printers aren't often used in aircraft applications, so generally we just choose next without checking the box use Windows printer. And we have nearly finished configuring the survey, at least in its basics. So we click Finish. The screen will change. The magnetometer configuration screen will appear again. Again, the software will send configuration messages to the magnetometer. And finally, the program will automatically resize the windows to make a reasonable display of windows. Some of these window features can be customized. A common customization of the magnetometer windows is to display the signal as a digital number rather than as a moving trace. So if you move the mouse inside the signal window, right-click and choose Slot Signal, we get the Signal Setup dialog box. We can click Use Digital Display Only, and we can choose digits after dot 0 in order to display an integer number such as the signal level that is reported by the magnetometer. Once we click OK, the appearance of the signal slot changes, and now we have a single number in the center that indicates digitally the amount of signal that's being produced at the sensor. Further customization includes the creation of mini windows to digitally display other data that can be helpful to an operator when flying a survey. One of the most popular additional digital displays is the mini window. We click on Configure, choose Mini Window. A mini window will appear. We right-click, choose Edit, and we get the mini window configuration. I can choose a channel to display. In this case, we're going to first display the magnetometer field, which is GeoMag Mag. I'm going to add it. I'm going to choose an update interval, in this case 500 milliseconds, or half a second. Under Appearance, I'm going to make the annotation MAG, just to let me know that this is a mini window for a MAG, or magnetometer. And I'm going to show the units as space, lowercase n, uppercase t, which will show that the units are in nanotesla. In digits before dot, we'll leave it at 5, and digits after dot, we'll make it 3 to match the output of the magnetometer. Now we'll click OK. The magnetometer field is now being displayed in a mini window. If I click in the mini window, then I can drag the mini window. As long as I drag the mini window within the magnetometer window, which was the window in focus at the time I created the mini window, the appearance will be as you see now. If I move the mini window outside its parent window, then the mini window's frame will change to show a standard window style dialog box. The mini window can be resized. As you resize a mini window, the text being shown in the mini window will also resize, and the program will attempt to keep the text readable at all times. Other popular mini windows to create are mini windows for latitude and longitude from the GPS. So I click on Configure and choose again Mini Window. Right-click, choose Edit. In this case, I'm going to choose GPS Longitude, add it. I'm going to display it once a second. I'm going to say the annotation is longitude by saying LON. And I will display this as degrees and minutes. So I'll call the units DM. Digits before dot can be quite small. 3 is a good default value for latitude and longitude displays. Digits after dot to give us some precision in the fix on the screen, we can make that 4. For the format, we will choose degrees and minutes. We'll say OK, and I'll move this, and now we'll have a longitude display. In this case, the longitude display is empty because there is no fix from the GPS. Our GPS antenna is in a location that does not afford measuring signals from GPS satellites. Similarly, we can create a latitude display. If you just create displays for latitude and longitude, you should take care to make sure that they are that both displays display in the same unit. So if you choose degrees, minutes, and seconds for one, it's best to choose also degrees, minutes, and seconds for the other. The GPS window has some special characteristics. If you click on any particular part of the GPS window, the program will attempt to display that part of the window in the center, that part of the map display in the center of the window. So if I click exactly on the central meridian and equator junction, that will snap to the center of the screen. If I were to click in the center of Australia, or the center of South America, that part will center on the screen. If I click in the ocean, it centers on the screen. Here's Australia centered. And here is ocean. And here's a piece of Africa in the center of the screen. And here again is the central meridian and the equator centered on the screen. When the GPS fix is active, the screen will snap to the GPS location. To record data, one may click on the Not Logging button on the upper right portion of the screen, or one may click on File and click on Start Logging, or one may type Control-S, keyboard combination. Any of these will start logging. When a survey is first created, it is created with a line number at 0, and the line number displays on the bottom of the screen in a small window. Also displayed on the bottom of the screen is the current date and time. When we start logging, data that is available will be logged to hard drive. Data that is being logged to hard drive will show as incremental numbers in the status windows for each device. In this case, the GPS is incrementing, showing that there's some data being stored for GPS, even though we have a warning condition for GPS. And magnetometer is showing data being recorded. INT is a device for the interpolator. The interpolator will not function without a fix, and so there is no data being recorded by the interpolator. When we stop logging, and we can stop logging similarly 3 different ways. We can click on the Loggy button. We can click on File and choose Stop Logging, or we can type Control-E keyboard combination. Whenever we do that, the line number will increment by 1. The line number is a number. It increments every time you stop logging. So you can always see either the current line if you're logging or the next line that's going to be recorded by looking at the line number. The next line is displayed if we're not logging. The current line is displayed if we are logging. When you have finished a survey for an area and you wish to create a new set of files, survey files, whether because you're going to a different area or because you want to have files that contain just data for a limited amount of time, you can easily create a duplicate survey. First, one terminates the survey that is running. We click File and say Terminate Survey, or we can use the keyboard combination Control-T to terminate survey. MagLog asks whether you're certain do you want to take this action. You click yes if you are, or no if you're not. And MagLog will shut down all of its data logging and data gathering processes and present you with an empty MagLog screen. To create a new survey that is identical in all of its setup to the survey that you have just been running, we click on File, we choose Start New Survey, we pick a location for the survey. In this case, we're going to again pick Video Demonstration. We enter a new unique name in this directory for the survey. Click Save. And from the Start New Survey dialog box, we click the radio button, same hardware setting as last survey. And we click OK. And we wait. And MagLog will create a new survey with all of the settings of the previous survey, except that we'll be using the new survey name, and variables such as the line number will be reset. The mini windows appear. The locations on the screen are the same. We can see that the line number is now 0. And in general, the behavior of this survey, which has a different name, is the same as the previous one.
Pricing and contact information can be found on our website at www.geometrics.com, or simply call us at 408-954-0522.